Hi. When I was a kid, whenever I'd go in the kitchen or the bathroom, I'd look at the tiles on the floor and wonder, what can we say about all those pretty patterns? How could I continue them under the bath, say, where I can't see them right now? Well, if you told me that 20 years later I would do this as a job, I would have told you, ha, that's not a job. Yet, here we are. An important question you can ask about those tiles is, how many of them do you need? That's a very important question if you want to tile a bathroom. Well, any tiler could tell you that the amount you need is approximately the area of the bathroom divided by the area of each of those individual tiles. Now, those tiles are a one-shot deal. You don't want to have any left at the end. You don't want to miss any. So you add a number of them enough to cover the perimeter. And the reason you need to do this is because the shape of the tiles don't fit perfectly inside the shape of the bathroom. Now, if you're in the bottom left corner case, this is not a problem, because the area is much bigger than the perimeter, so your first estimation was still pretty good. However, in the top right corner case, the perimeter and the area are of comparable size, so was your first estimation using the area still good? Well, my field, asymptotic analysis, could also be called estimation science. As such, we have all the right tools to answer these types of questions. Now, you can remark that, say, in any of those two cases, if you have one of the tiles that's around the edge, you will cut it to make it fit. And maybe the part that you cut, you could use it around another part of the edge. And as such, your estimation using the perimeter would be a gross overestimation. Maybe you need less than what you added there. Well, one field that understands how to deal with those type of cancellations is in the physics of waves and vibrations. Here, when you have a wave that's comprised of many smaller waves of different frequencies, you might have constructive or destructive interference. And this destructive interference would be exactly this, cutting on one side and putting on the other side. A very important theorem in harmonic analysis tells us that actually counting those tiles is exactly the same thing as calculating the amplitude of a wave whose frequencies would correspond to the corner of those tiles. And that's exactly what happens. In my PhD work, I have shown that in the top right corner case, we have destructive interference. The area estimation was a good one. We don't need to use the perimeter too much. Well, now you might tell me, a PhD in counting bathroom tiles, is that really serious? I mean, do we have more important things to do? Well, you'd be right, and that's the beauty of mathematics. The same model that I'm talking to you about today using bathroom tiles is the same model that tells you how many energy levels are available in a crystal, or that tells you how whiskey slushes inside a glass. Well, that's it. For the physicist, for the tiler, for the whiskey aficionado, the mathematics on which I'm working explains parts of their everyday life. Thank you.